And so what this firm does is it produces any and all units where the marginal revenue is at least as large as the marginal cost and stops where marginal revenue is equal to marginal cost. Right? So it stops at QM. It then chooses the price such that it sells exactly QM units, i.e. it charges PM. Okay? So let's look at doing this mathematically. And so we're going to have marginal willingness to pay equals 100 minus 1/2 Q. And we're going to have marginal cost is equal to 20. Right? Well, if you are a profit maximization, right? You're going to set marginal revenue equal to marginal cost. Marginal revenue is just going to be twice as steep. So what we have is 1/2 Q. We multiply that times 2 to just get Q. So the marginal revenue is equal to 100 minus Q equals 20, which tells us that the monopolist quantity has to equal 8. The price that the monopolist charges, well, that's just going to be equals the price such that exactly QM units are sold equals 100 minus 1/2 80 is equal to 60. That's profit maximization. A common mistake is to assume that the monopolist wants to maximize revenues and not profits. And so what I'm going to do is try and convince you both intuitively and graphically what the problem is with revenue maximization. Right? And so if you wanted to maximize revenues, and I tell you that this is a bad idea, and before I start, let's just get the intuition right. And so if I offered you the deal where I will give you $5 for something that costs you $20 to give up, would you take it? I mean, you would increase your revenue by $5. And when I put it that way, it's like, well, of course not. You know, I wouldn't do something that has a $5 benefit if it has a $20 cost. Right? And this is going to be the problem with revenue maximization. Because there are going to be certain things which might increase your total revenue, but you're not going to do it if it increases your cost more quickly than it increases your revenue. So this is the intuition which we're going to show. Right? And so what revenue maximization would be in our graph, revenue maximization, would say that you would do all units where the marginal revenue is positive. Recall that this is the unit elastic portion of the demand curve, unit elastic demand. Right? And if we set marginal revenue equal to 0, we would get 100 minus Q is equal to 0. And what I will call QRM, the quantity that maximizes your revenue, is therefore equal to 100. Right? So you, of course, are a profit maximizer, so you stop at 80. But if someone else was kind of foolish and wanted to maximize their revenue, they would continue to produce 100 units. Right? Let's return to the graph that we have. Right? And so let's put this in. We have the price that maximizes profits at 60. We have the quantity that maximizes at 80. And here we have Q revenue maximizing at 100. And now we can see graphically what the problem is. Right? For every unit between $80 and $100, the amount of money that you get to put in your pocket by selling that unit is given by the blue line. That's your marginal revenue. And recall, that takes into account the fact that in order to sell more units, you've got to offer a discount to some people. Right? And so, yes, it is the case that along that blue line between 80 and 100, the marginal revenue is cost, right? The quantity effect is bigger than the price effect. The problem is for all of those units, right, the amount of money they put in your pocket is less than 20, and 20 is the marginal cost. So for all of those units, these are cases where, yes, it increases the total amount of money that's in your pocket. That's good, but the bad thing is the amount of money each unit puts in your pocket is less than 20, and the cost of producing this unit is 20. Right? And so you don't want to produce all quantities where marginal revenue is positive. Right? You only want those units where the marginal revenue is at least as large as the marginal cost. Which also says that if your marginal cost was 0, then profit maximization would be the same as total revenue maximization. Cool. So that is our standard monopolist. Right? To summarize, what we did is, we specified an inverse demand, which is the same as marginal willingness to pay as a function of quantity. Right? We specified some cost. In this case, we assumed constant marginal cost. Right? If that's our cost function, each time you increase quantity by 1 unit, you increase your cost by C. Right? And the monopolist solution is just to produce QM, that quantity where marginal revenue is equal to marginal cost. That's the optimal quantity. And we can just do that because that just says if quantities are discrete, right, you can't choose continuous quantities, you would want to choose the largest quantity such that marginal revenue is at least as large as marginal cost. Right? And so that's going to give us QM. That's going to give us the amount that the monopolist wants to sell. Given that amount, it charges the highest price possible such that exactly those number of units are sold, i.e. it goes up to the demand curve, and that tells the monopolist the price. Right? We established that it must be on the elastic portion of its demand curve, right? Because if demand was inelastic, right? That says demand is inelastic. That means consumers don't think that your product has any good substitutes. Right? Inelastic demand means that if you increase the price, your total revenue goes up. And if you increase the price and your total revenue goes up and your costs go down, then that's got to be profit maximizing. And so any time that you're on the inelastic portion of the demand curve, you should increase your price. Right? We can calculate profits as well, but profits we're going to require that we include the fixed cost as well. Right? Because what we just drew only had marginal costs in there. Right? And marginal costs only tell us about variable costs. Right? Hasn't told us anything about fixed costs. Right? And producer surplus is not the same as profits. Right? Producer surplus is going to be equal to total revenues minus variable costs equals amount left over to put towards fixed costs. And so what this tells us is that profits are going to be greater than 0, where I use the Greek letter pi for profits. Profits are going to be greater than 0 if your producer surplus is greater than your fixed costs. And this makes sense, right? So After living in the greatest city in North America, New York City, I then moved to the middle of nowhere. And this middle of nowhere had approximately 10,000 people in it. And if there was a French restaurant there, they would have had a monopoly. Right? But apparently, right, even having a monopoly in Williamstown, Massachusetts, in a French restaurant is not lucrative enough to cover the fixed costs of running a really nice French restaurant. As a result, I had no French restaurant. Even though, had someone opened up a good French restaurant, they would have had a monopoly. But the producer surplus that they would have gotten would not have been sufficient to cover the fixed cost of production. Damn, that sucked. All right.